the Earth, or don't panic and always carry a towel. Do all of you recognize that? It's from the Hitchhiker's Guide to the Galaxy, a trilogy of 4 books, and that's my favorite phrase. Don't panic and always carry a towel. So let's see what asteroids are. First of all, I'm going to probably talk about stuff you know about. An asteroid is a minor dwarf planet orbiting the sun, like Pluto. Appears, if you look at it through a telescope, it's going to look like a star. If you look at it through a telescope, you have to get these pictures of asteroids at the bottom of the page. You have to get close up to them with some kind of satellite to get a picture that shows them bigger than a star image. It's very old rock from the time the solar system was made, and it's rock, metal, and even water and sugar. We'll talk about that a little bit. My favorite particular asteroid is the asteroid called Situ. Asteroid B6, I can't see it. Okay. Asteroid 46610 Situ was found and really named for the one that the Little Prince lived on in The Little Prince. And it was discovered in 1993. And I just think that's charming that they named it asteroid Situ. B612. There is a B612 society that wants to search for near-Earth asteroids. The B612 organization, there's open source software if you want to get the orbit of a satellite, orbit of an asteroid. This is the choices that I found. The Asteroid Institute team is a location where you can find software for asteroid orbits. The B612 has it, and it uses Python. So if you know Python, you can probably have a good time with it. Python is one of the modern languages. In my day, we used Fortran, but hey, nobody uses that anymore. The first asteroid was discovered on January 1st, 1801. It was thought to be a planet because they thought it was so big that it was actually a planet for a while. They put it in the solar system kind of between Mars and Jupiter. But they finally discovered that no, it's not a real planet. It's a dwarf planet like Pluto. It does contain water, and its diameter is 950 kilometers. And there are asteroids that have little astronauts. Do that again. This is the asteroid Ida, and Dactyl, which is right there, the little dot, is circling Ida. And there are a bunch of these. They have their own little companion. Pluto has 6. Now, asteroids wander around the solar system almost at will. And now and then one comes close enough to the Earth that the Earth captures it and makes another moon. And in 2020, we had 2 moons for a while. This is the size of a bus. This particular asteroid was the size of a bus. And it was a mini moon in 2020. And there's usually one captured every so often, and we get another moon for a while. Then we have strangers that come by. You may have heard of this one. I can't really pronounce it well. Uma, Uma, Umua. And it was with an odd shape. It came from the outer space, visited us for a while, and then left. So we get oddballs from other places now and then. But Bennu is the asteroid I want to tell you about, a lot about, because NASA's OSIRIS-REx mission was destined to go by Bennu and capture samples from Bennu and return it to Earth. This was OSIRIS-REx. It was launched in 2018, and that's Bennu, the asteroid, getting closer and closer and closer. It was named after a young man named it because he said it looked like an Egyptian stork. I don't know how he got that, but he said it was an Egyptian stork. Okay. OSIRIS-REx is the first US mission that we sent to collect a sample. Japan has done this. They've done this as well. But we were the first one to drop off a capsule. The capsule was collecting samples from Bennu, and then they renamed the OSIRIS-REx OSIRIS-APEX and sent it on a new mission to explore an asteroid Apophis in 2029. So this is a asteroid satellite that's going to have a lot of fun. It's dropped off the sample at Earth, and it's on its way to Apophis now.
We have arrived.
Preliminary survey is a series of maneuvers about 2 days apart and consists of 5 hyperbolic flybys, so essentially a straight line relative to the asteroid. And we do 3 of those over the northern hemisphere, we do 1 over the equator, and we do 1 under the southern hemisphere. And that allows the scientists an opportunity to collect lots and lots of imaging data that aids in building shape models and also eventually in sample site selection. At the completion of a preliminary survey, which is about 3 weeks, we'll drift away from the asteroid, come back, and insert into orbit on December 31st.
What's really groundbreaking about the navigation on this mission is the size of Bennu. Bennu is the smallest object to ever be orbited by a spacecraft. The gravity is so low that we can effectively maneuver all around the asteroid with very little fuel cost.
There's the sample pickup. And it was made by Goddard. Whoops, I didn't go on there. There's the sample pickup on return to Earth. And this is what it looked like when it returned to Earth and they opened it up. And these are all pieces of stuff that jumped in. The real samples are underneath this, but these were all dust from Bennu. They're picking it up in the desert where it landed. But this one is a YouTube. I think I can play it. They have analyzed.
The origin of life is one of the deepest mysteries in science, but the clues to solving it have been buried by plate tectonics, the water cycle, and even life itself. For answers, scientists are looking beyond Earth to primitive asteroids like Bennu, the target of NASA's daring OSIRIS-REx sample return mission. Now, material from Bennu is revealing a lost world from the dawn of the solar system, with the right conditions to foster the building blocks of life. When scientists examined the Bennu samples, they discovered evidence of a wet and salty past. Among the dark rocks were bright veins of salts that form on Earth when brines evaporate from alkaline lakes. Searles Lake, California is home to a mineral called trona, which is mined as a source of baking soda. Scientists found microcrystals of trona and other evaporite minerals within the Bennu samples, indicating that they once held pockets of sodium-rich water. Such brines are ideal for cooking up organic molecules, carbon-based compounds that are the stuff of life. Bennu is a carbon-rich asteroid, and its samples are chock full of organics, including amino acids and nucleobases. Amino acids can be bonded together in long chains to build proteins, which give cells their structure and function. Life is constructed from a set of 20 amino acids, 14 of which were identified within the Bennu samples. Nucleobases are the genetic components of DNA and RNA. All 5 nucleobases were discovered in the Bennu samples, a first for extraterrestrial material collected by a spacecraft. In addition to organic molecules, scientists found that the Bennu samples are surprisingly rich in ammonia. On Earth, ammonia is a common agricultural fertilizer. It readily evaporates at room temperature, but is more stable in cold environments, like those found in the outer solar system. Bennu is too close to the Sun to retain pure ammonia, so its samples must have formed during a more distant, frigid past. Salts, organics, ammonia. Thanks to OSIRIS-REx, we can now piece together these clues to tell a likely origin story for asteroid Bennu. 4.5 billion years ago, in the nascent solar system's outer region.
We'll stop it there. But you can look up the YouTube and watch the whole thing, because it's a wonderful story.
Reaches a world of rock.
Now, where do asteroids hang out? We care about that. There are a whole bunch in the main asteroid belt between Mars and Jupiter. And Jupiter has it drags its own asteroids around with it, the Trojan asteroids and the Greeks. The Greeks and these are named after the Trojans, these are named after the Greeks, because the Greeks won the war, so they lead in the orbit. And they are a place that asteroids hang out. But I have a better one. This is actually showing you every dot is an actual dot of an observed asteroid. Every white dot and green dot and red dot and orange dot. So that in the asteroid belt, you see it's really big between Mars and Jupiter. And then there's the Greeks and the Trojans and the Hildas. They have lots of names for asteroids, but each dot is a known asteroid. Then there's the outer asteroids. Those were in between Mars and Jupiter, but if you go out where Neptune is, out here, this is Neptune's orbit, and here's Jupiter and a cluster of all the asteroids around Jupiter and in between Jupiter and Mars. But these are called the Kuiper Belt objects, named after Kuiper. The Minor Planet Center tracks them all. So these are all real ones. Each dot is a real asteroid tracked. There's where Pluto is right now, in case you were curious. In fact, Pluto, then and now, the first picture is Pluto, what we saw before, and after the mission New Horizons went by, this is what Pluto looked like, which I think is kind of cute. Pluto. Now, before I play this, there is the chief guitarist in Queen, the music group Queen. Have you heard of that? The music group Queen, the chief guitarist is Brian Mason. It turns out he's an astrophysicist, and he was on the New Horizons trip, New Horizons mission. And he wrote a song to go with this video, as if he were writing it for Queen.
T-minus 15 seconds.
Ready? Roger.
11, 10, 9, 8, 7, 6, 5, 4, 3, 2. We have liftoff of NASA's New Horizons spacecraft
The revelations of New Horizons may help us to understand better how our solar system was formed.
Okay, I'll stop it there. But it's kind of neat that the lead guitarist on Queen is actually an astrophysicist, PhD. So he was on the New Horizons mission. Now, you've got the main belt asteroids, those are the ones between Mars and Jupiter, and you've got the Kuiper belt asteroids. And the problem is everybody gets involved. Jupiter tosses asteroids around all the time. It's the big honking master of the outer solar system. Even Neptune tosses them around. And in here, they get hit by Earth, they get hit by the moon, they hit the moon, they hit other planets, everybody. Asteroid meets Earth. Well, if it's going to meet us, it's going to burn up in the atmosphere, maybe, and that's a shooting star, a meteor shower. Some burn up in the atmosphere totally, doesn't reach ground. Some explode in the atmosphere. Those are air bursts. And those are asteroids, meteors that have smaller than 100-meter diameter. There's a airburst. That's what you'd see in an airburst. And this particular one was 8.5 kilometers up. And it was the one that did the Tunguska event in Siberia. The 1908 June 30th event in Siberia, and it flattened a lot of trees. Well, that particular image is not too helpful. It doesn't give you a sense of the scale. So I want to show you, this is if you can see it, there's Washington, D.C. here. The light green, Washington, D.C. And here's the meteor that did Tunguska. It would essentially destroy DC. So that particular flat freeze was actually rather big and beyond. So it would flatten the city if we're thinking of it locally. And in 2013, there was a Chelyabinsk. Did all of you hear of the Chelyabinsk event? It was a airburst. 2,000 people were hurt. The burst occurred about 30 kilometers up. It's going to burst in a minute. And much greater than Hiroshima, it released atomic energy release. He was and didn't expect that. So he didn't expect there to be a bang, and windows were blown out, and people were hurt by flying glass. But we'll stop it since you don't need to see the hurt people on the ground. At any rate, 2,000 people were hurt, and it was a burst about 30 kilometers up. That occurred in 2013. So some explode, air bursts, some land and become a meteorite. If they land, we change their name to a meteorite. Terminology. We're going to do something new here, so we've got to have more terminology. You can't just call them meteorites. Meteorite is an asteroid on the ground. 94% are stony. That means they look like a stone. If you kick it with your foot, you're going to think it's a stone. It's not going to look like a meteorite unless you cut it open. And if you cut it open and see these round circles in the slice you cut open, then you've got a meteorite. But you have to cut the rock up. So most of them are silicate stone. Silicate, that's the stone. 5% are iron or iron nickel. Much smaller percent. You can actually tell an iron meteorite on the ground because it will look different than the stony ones. It will be dark and it will be heavy because iron is heavy. And 1% are stony iron, a sort of combination of half and half. Some contain organic compounds. We know that because we've seen them now. And on average, there's more precious metals than the richest known ores on Earth. If you want platinum, you go to those were the meteorite asteroid hunters in early science fiction. They were hunting for platinum and rich ores. Where are they found on Earth? Well, they're mostly found, if you think about it a little bit, they're found in Antarctica. Some are found in Africa, a few in a few other places, a little bit in Asia, South America, but why Antarctica? This is another YouTube that I'm not going to play, but whoops. I don't want to play. I want to get past it.
My name is Nina Lanza, and I'm a staff
I guess I'm
scientist
not
at
going
Los
to get
Alamos
past
National
it.
Laboratory. I will be going out to Antarctica to search for meteorites with a team called the Antarctic Search for Meteorites. Antarctica is a great place to recover materials that came from space and fell onto the Earth. Meteorites fall on the Earth at the same rate everywhere, but they're usually falling into places that we can't necessarily access, or places that are going to be geologically very active. So Antarctica is different because it is this beautiful, smooth, white sheet of ice. So meteorites fall into this ice and then become entrained. So it gets trapped in this ice, and then the ice will sublimate, and that means it'll evaporate without turning into liquid. So the ice disappears, and then all those meteorites that have been trapped for thousands and sometimes millions of years will be exposed at the surface. So we didn't have to leave our planet to sample all these different bodies within our solar system. All this material has come to us and is waiting for us in Antarctica.
That was Los Alamos.
If I actually managed to...
Oops. Don't want her. There's a field of meteorites. Look at them all. Look at all the dark. That's why it's fun to go to Antarctica. I haven't been, but people get to do this. It's run by the National Science Foundation. And they pick up, they describe where they picked it up, what size it is, all the information you'd want to know, and then they pick it up and cart it back to whatever country they're from. Different countries work this area. In the United States, it's the Lunar and Planetary Lab in Texas. Houston, Texas. So some land and become a meteorite. We know about those. The big meteorites leave the ones that have a diameter bigger than 1 kilometer are going to leave craters. Here's the moon, covered in craters. Lots of asteroids hit the moon. Kind of protects us from them. Do other planets get hit? Yeah. There's a binary asteroid on Mars. There's a small world on Mercury, like this. And then the impact features on Jupiter from comet Shoemaker-Levy that came by 15 years ago, no, 20 years ago. And here is a fresh crater on Mars. You can tell it's fresh because the color is different in different parts. It's 15 to 16 meters in diameter, and it occurred sometime between 2016 and 2019, the meteor, right, that fell there. That was Mars. Now, where do they fall on Earth? On land, they're all marked for the big ones with dots. And the bigger the dot, the bigger the asteroid. Most of them fall in the water, so you wouldn't know. They fall in the Pacific, go to the ground. But the biggest that have fallen, I think the biggest craters are in Australia. But this is a map of recognized, this is a recognized impact structures on Earth. And you notice it's not where they're mountains, because you wouldn't see them in mountains so much. It's harder to find. You need a big dusty plain like Antarctica or Australia is a good source, and certain places in the Great Plains. This is the biggest iron meteorite. It's in Swaziland. And she's standing by the largest iron meteorite that exists. It's 54,000 kilograms. It's the largest bit of natural iron on Earth. And they finally turned it into a place for tourists. It wasn't for a while, but now they say beware of falling meteorites. They warn you. The meteor crater in Arizona, I stuck in the pyramids to give you a sense of scale. The meteor crater is very big. If you've been to Arizona, you can visit the meteor crater. It's not hard to find. And the Sphinx. It was about 50,000 years ago, this particular one. And here are the people on the visitor platform. So you can see the scale of the meteor crater in Arizona. Now, you all know about the Chesapeake Bay. It's special because we're Marylanders after all. And the Chesapeake Bay crater appeared about 36 million years ago. It burst, it landed, and it went underground. It dug a crater, and that's the bolide that's underneath the Chesapeake Bay. And you can still get samples from the bolide if you go down to the bottom. The bottom of the Chesapeake Bay is essentially the bolide of a meteorite. And the original asteroid was about 3 kilometers wide. So it essentially opened up this for water to flow in and form the Chesapeake Bay. It didn't splash the Chesapeake Bay, it just broke open the land. This is where the bolide sits. In the largest crater is from a twin asteroid with diameters of 10 kilometers, and that's in Australia, Western the western edge and the eastern edge of this particular crater. Very big, 10 kilometers in size. That's a big asteroid. Well, now the Cretaceous Tertiary event was a bad day for asteroids, for dinosaurs. The asteroid probably wasn't happy about it either, but the dinosaurs said, "Oh, sure, we've got a disaster plan. We're safe." Well, this particular crater was more than 180 kilometers in diameter. 65.5 million years ago. It was a fireball. That meant it exploded up in the air, and then pieces fell to Earth. The fireball was about 10 kilometers in diameter. And I'm showing you an old map of where it fell, but if you put the modern map on it, it fell right there in Chicxulub in the Gulf of Mexico. And that's what they think did in the dinosaurs, that particular meteorite. Pieces, signals, debris from the meteorite was found all over the Earth. By the time they figured it was all over the Earth, they figured it must have really done a disastrous kill-off event. And it got rid of the dinosaurs and a lot of things as well. There. These are all sites of the bolide. So the big meteorites leave craters. The teeny ones, if you're a teeny asteroid, meteor, they fall as dust. And 44,000 kilograms of space dust hit the Earth every day. Oops, I'm sorry. To get rid of the cat. Down. And so it's because it's so much space dust, they have to include it in climate change models. Those are the teeny ones. Dust is 44,000 kilograms of space dust hit the Earth every day. That's a lot. Now, what are your chances of death? People care about this, and the National Safety Council put up heart disease is 1 chance out of 6 that you'll die of heart disease. A lot of people die of heart disease. Falls, 1 in 91. Opioid addiction, 1 in 96. And down to a whole bunch, earthquake, down to meteorite, 1 in 10 billion. So your chances of getting hit by a meteor, are pretty slim. It's just not very likely. You probably get hit by the dust all the time, but not by a chunk of rock. You can look this up on the web. Look under the National Safety Council, and it will list today's list of what the order is. They now define firearms discharge as different kinds of firearms. It's changed a little bit. But one meteorite has hit a human being, authenticated. Her name was Mrs. Hodges. She lived in Alabama in 1954. A 4 kilogram stony meteorite fell through her roof, bounced off a Philco radio that she had playing in the house, and hit her. She was asleep on the couch, hit her on the side, gave a big bruise right on her kidneys, and bounced off the large radio, and then where she was taking a nap before hitting her. In fact, there's the meteorite right there. You can see it's a big rock to hit you. And there's the hole in the ceiling right there. Mrs. Hodges. Her family donated the meteorite to the University of Alabama Museum in Tuscaloosa. So somebody has been hit. She was in the hospital with the injury. So you're going to hit people? Congress has to get involved. And this is the old days. In 1990, now that we can detect asteroids, we got to detect Earth orbit crossing asteroids, because they're the ones that are going to fall on us. And the means to destroy or alter orbits should be defined and agreed upon internationally. Congress passed that in 1990. So now that we've got a new way to do this, we've got to have more terminology. We can't do this without terminology. So we get near Earth asteroid, that's less than 4.5 million kilometers from Earth. The near Earth object is essentially a near Earth asteroid. Potentially hazardous asteroid is one that is less than 750,000 kilometers from Earth. And it's 384 kilometers to the moon. So that gives you a sense of the scale of what could be potentially hazardous asteroid. So we've got NEA, NEO, PHA. It's NASA speak. So they have to use terminology. Now, why are they hard to find? Because they're tiny and they're traveling very fast. So that they're dark, that's the inverse square law, that it's in between the two bright objects there, stars, is the asteroid, and they're fast and difficult to image. There it is moving on 3, just not very far apart images. So that's why they're hard to find. You've really got to get creative about how you're going to track these things down. So there was in 2012 an asteroid called DA14.
It won't be long before an asteroid named 2012 DA14 makes its extreme flyby of our planet. About half the size of a football field, DA14 should come within 17,200 miles of Earth on February 15th. Although the space rock will pass within the orbit of many of our geosynchronous satellites, scientists in NASA's Near-Earth Object Program Office say there's no danger of a collision. Still, they're keeping a close eye on DA14.
Even though it's getting very close, it won't reach naked eye visibility. But if you have a pair of binoculars and you know where to look, and you happen to be located in Eastern Europe, Asia, or Australia, you can observe it going from the south to the north, passing closest approach over Indonesia.
Closest approach is estimated for 2:24 p.m. Eastern Standard Time Friday. NASA TV's live coverage from the Jet Propulsion Laboratory in Pasadena begins at 2 p.m. Eastern Standard Time. Later that afternoon, NASA TV will carry live views of the asteroid that may be available from observatories around the world as DA14 makes its exit from our galactic neighborhood.
So
it won't be long before
So this is a comparison of DA14 on the left and the Chelyabinsk, the one that caused the Big Bang in Chelyabinsk, Russia, on the right, to scale in a football stadium. And I think people tell me they know which football stadium this is. I'm not a football aficionado, so I don't know what stadium this is, but people recognize it, that they use to compare the two asteroids. So what are we doing? What are we doing to watch for these things? Literally everybody's doing it. Everybody's searching. They're government-funded surveys, that's called Space Guard. They're university-based research and discovery programs. That's like the Lunar and Planetary Lab. The Harvard-Smithsonian Minor Planet Center tracks them all. The Jet Propulsion Laboratory tracks all near-Earth objects, NEOs. Private observatories track them, private foundations like B612. Amateur astronomers are good at it. And remember that solutions are cheap compared to the consequences. It's a 100% certain that we'll be hit by a devastating asteroid, but we're not 100% sure when. So it's coming, we just don't know when. It's come before. And there are people who study this. Potentially hazardous asteroids, they're tracked. There are 2,304 of them have been, 2,304 have been found so far. But this is the ones around Earth. There's Earth, Mercury, Venus, Earth, and Mars. 37,000 of them of near-Earth asteroids were known as of January 1st this year. And of those, 2,304 were potentially hazardous. So people are really tracking these. I mean, they care. They follow them, they get their orbits. The middle solar system, potentially hazardous asteroids. Here they are laid out. Mercury, Venus, Earth, Mars, and Jupiter way out here. But they're all coming into us. Now, if you make a chart, and astronomers and scientists love charts. So all near-Earth asteroids, as they're found, this is the blue. Each year, it goes up another notch as they find more. Blue shows all the near-Earth asteroids, but those which have a diameter greater than 1 kilometer is red. And about 90% of those have been detected. So the dangerous ones, we know about 90%. That leaves 10% out there ready to do us harm. We have to keep looking. Astronomers are clever, the people at JPL. They made up a scale for how bad an asteroid hit could be. 0 is nothing. 1, a little bit of damage. That was 2012 DA14. If it hit us, it'd do a little bit of damage. Chelyabinsk would be a Torino scale of 3. Tunguska, which would destroy Washington, D.C., was a 5. And then down here at 10 is the Cretaceous Tertiary event that killed the dinosaurs. That's a worldwide event. Is it doing my talking down at the bottom?
It just started doing that. I'm not sure why.
I'm not sure why. It's picking up what I'm saying. I don't know why. Any rate, that's the scale scientists use to determine how bad it's going to be. What Torino scale do they give it? Here's the expected impacts on Earth. Hiroshima-sized impact way up here at year down this way. TNT equivalent in megatons this way. Tunguska was here. Once a century, you get a Tunguska event. Once every 10,000, 12,000, 15,000 years, you get a global catastrophe. And every 100 million years, you get a Cretaceous Tertiary event. So people have really worried about this kind of stuff. They now do mathematics on it. Apophis is going to come by soon, 2029, and it means in Egypt, ancient Egypt, Apophis means death. So Apophis is the snake of death underneath, and the sun is going at nighttime, is sailing on top of the death snake. Apophis is going to approach the Earth. It has a Torino rating of 4 for a passage in 2029, Friday the 13th of April 2029. Apophis, which means death, will approach the Earth. Now, they've studied it to death. They were worried about this one, and they now found out it's going to miss us. So its orbit's going to be close to Earth, but it's going to come very close and just get near us, but that's all. There's the moon, and this is how close it's going to be. So they recalculate the orbit almost every day, and they found out it's going to miss us. So we're safe in 2029. The next passage, we don't know. It's 325 meters in diameter. So it's going to miss us. DART. DART was a funny one because DART has a companion meteorite called Dimorphos. And NASA sent up a satellite to collide with Dimorphos to see if it could knock it out of its orbit. This is, what you test for if you're going to see what you can do to an asteroid. The collision shortened Dimorphos' orbit by 32 minutes, greatly in excess of the predefined success threshold of 73 seconds. So that was it crashing into they crashed it into Dimorphos and let it see if it would knock it out of its orbit. This was another near Earth, another YouTube. Other objects that could hit Earth. Coronal mass ejections hit Earth. They mess up our electricity. Comets. We go through the tail of a comet frequently. Space debris. Here's the Earth with the debris, space debris about it. I mean, we're really cluttered up there with asteroids, with satellites, missions that have been turned off, new missions. In fact, even fallen rocket parts come to ground. In 1966, the Icarus project at MIT inspired the 1979 movie Meteor, which was one of these movies that was apocalyptic. I mispronounced that, didn't I? How do you pronounce it?
Apocalyptic.
Apocalyptic. So you have to do the thing as a worldwide effort. You can't do it one country. Can't be one country to do it. it's got to be everybody involved. So what can we do? We need to find it. That's the first thing, because it's going to be a potentially hazardous asteroid. We found 90% that are going to not hit us right now, but we need 10% still out there. We could kick it. Maybe that would knock it out of its orbit. We could blow it up. Maybe that would help. We could push it. And we could use laser beams. I'll tell you about those in a second. This is what can you do? Find it. Kick it, blow it up, push it, laser beams. This is the kinds of things they study. Now, if you're going to find a potentially hazardous asteroid, you've got to smack, bump, nudge, deflect it with an object like the Deep Impact mission. This is possible if you can bump it, if you find it years to decades in advance of the time it's going to come by Earth. You've got decades of work to do to build what you're going to bump it with. We don't have stuff on Earth built to do this. So if it's detected early enough, years to decades of warning, then kinetic impact where you bump it out of the way might work. Now you could destroy it with a nuclear weapon. This is actually more difficult to do because it takes years to decades of warning. You have to find it decades in advance and then build the nuclear weapon that you're going to do this with, and then hope that when you blow it up with nuclear debris, that all the nuclear debris doesn't fall back to you on Earth, which is a big chance. That's very likely to happen. So vaporizing it with a nuclear weapon may be the fastest way to do it, but it's not a good idea. Slow push-pull. Well, you get a big, heavy object up there, and you just, gravity pulls it slowly out of the way. As detected early enough, decades of warning, if you have decades in advance, you can build something to push it out of the way slowly by tugging it. Apophis. There's the Apophis. OSIRIS-REx, remember, was renamed OSIRIS-APEX and aimed at Apophis. It will reach Apophis shortly after it's going to encounter Earth, where it will begin an 18-month mapping of the surface. So an alteration of this size, then the mission will have to prove that it's possible to predictably alter the path of an asteroid by approximately 100 meters. We haven't proven that yet. We've proven 32 centimeters, but not 100 meters. So they're worried about Apophis. Well, we now know it's safe. It's not going to hit the Earth. But Apophis is one they study, because it's going to come close enough to do this with. Laser beams. This is very technically difficult to do. You put out a whole bunch of different satellites, each one with a laser, and they all aim at the satellite to push it out of the way. Bing it with a laser. But you got to have a bunch of satellites operating all in unison. This is technically very difficult to do, but that's something that they're thinking of. So what are the three most important things to do if you're going to mitigate against potentially hazardous asteroids? Find it early. The second thing you need to do is find it early. The third thing you need to do is find it early. That's the key. If you find it when it's just 2 days away, you don't have time to prepare for anything. So you need to find it decades in advance. That's why they have these searches for all the potentially hazardous asteroids. That means search and identify. Well, there's always next time. I mean, it's going to come back. I like the angry cat. Now, are impacts always bad news? It got rid of the dinosaurs, but we humans likely owe our existence and current position atop the animal food chain to these space rocks. The one that got rid of the dinosaurs allowed the little guys to grow. And so they show a Stone Age human right here, thumbing his nose at the dinosaurs. Don Yeomans headed up the Near Earth Object Program at JPL. So what can you do? Eat sensibly. That's heart disease. That's good. If you eat sensibly, you avoid heart disease. Wear your seatbelt. You avoid car collisions and death by that way. Now, if you want to protect against asteroids, you support astronomy. And that's the obvious conclusion to the talk, because you're going to support astronomy. But there are resources you can find from the National Academy of Science, Defending Planet Earth, the report. Jet Propulsion Laboratory has a near-Earth object program where you can actually plot all the near-Earth asteroids you're interested in. You can pull up their orbit, or you can ask your friendly local astronomer. And don't panic, and always carry a towel. So that's it. Thank you very much.
No, thank you. That was great. We'll unshare. Let me put a little spotlight on you. All right.
Oh, there. Yeah.
Yep. Yeah, spotlight. We're going to open it up for questions. If you have a question, you can put it in the chat box or raise your hand and I will call on you. I'm going to start it off because I have a question. I didn't understand one of your slides when you were showing the different asteroid belts, and you were showing that Jupiter and I think that Neptune were throwing asteroids at us. What does that mean? How
that
do
means
they throw
asteroid? Jupiter's big. It's the gravity boss of the solar system. So if a meteor asteroid gets close to it, it does a swing. Jupiter swings it around and shoots it in different directions. And the direction could be towards us or not. We don't know. Some of them, we found asteroids from Jupiter in the Antarctica. And we found asteroids from Mars. Mars swings them around and gets them going in different directions. So we know that happens. They get caught in the gravitational pull of the big planets, which then toss them randomly through the solar system. That's what the slide was supposed to show.
Gotcha. And I think that Shireen kind of asked the same question. She says that some meteorites are said to be from Mars. How do astronomers know that a meteorite is from Mars or from Jupiter? How do they know that it's from one of those other planets?
What it's made of. We know what Mars is the only planet entirely inhabited by robots. So we've got robotic data from Mars that tell us what it's like. So if a meteor bounces off Mars, and we know if we cut it open, it's going to have the same chemical distribution as Mars does. That's how we know it's from Mars. Now, Jupiter, different. Jupiter is all gas, so it's a little more difficult to tell. But we can tell if they come from Mars easier, or if they come from the moon. We found ones from the moon, but the moon caught it and swung it around and then dropped it on Earth. So we have to cut open the asteroid and the meteorite and study its chemistry. And it's from its chemistry inside that we know where it came from.
Great, thanks. And the dust that's in the air, are there, can you catch that in the atmosphere? How do they, can you catch that and measure it?
They actually measure it from the surface of the floor of the ocean. They can see the dust build up on the floor of the ocean from meteorite. It's made of the same stuff as the meteorites. So they know that's what it's from. And then if that's enough stuff that you can actually measure it on the floor of the Atlantic.
Okay, interesting.
Yeah.
So we have a question here. With all of the increasing space debris, does the risk of collisions increase? And if so, what would the impacts be?
Yes. The answer is yes, it increases. The more debris we get up there, the worse it is. And people shooting up spotlights, there are people doing that to light up the night sky. That's a terrible thing to do. But because you're putting more debris up there. And it will, if a space dust, something about the size of a penny, hits your International Space Station, it would knock it off its pins. It would tear a hole in it. So that's really bad if you have a collision.
Shireen asks, and I don't know how I always said it was the Kuiper belt, but you pronounced it different.
Kuiper. He was named Kuiper.
Objects have the same composition as main belt asteroids.
Pretty much. They're a little bit bigger, but pretty much. Yeah. Because we know where they come from when they impact Earth, if we get them and get to cut them open. But yeah, pretty much. It's a good question.
All right, Alan has, besides killing off the dinosaurs, is it possible or probable that an asteroid or multiple asteroids are responsible for creating life, since DNA components were found on?
Some scientists are pursuing that. That's an active area of research. Does an asteroid contain the right chemicals and meets early Earth, in its times when it's not, doesn't look like it does today? Would it be available to create life? And the answer is they're studying it. They think so. They don't know so yet, but they think so.
I'm going to follow up that question because I think there's also questions about water delivery on Earth from asteroids.
That'd be hard because the water has mostly crystallized. It's been so cold out there. Once you leave the warmth of the surface of the Earth, it's cold. And so the water would have crystallized and formed other elements. So it's not likely that you get liquid water from asteroids, meteorites. So it wouldn't be a good way to get water.
Okay. Are there any efforts to create a space junk remover to clear up the debris or some other mechanism?
Yeah, people are trying to do that and they can't figure out how to do it. They're trying to figure it out, but you've got you know where everything is. The Air Force tracks all this debris, but how you gather it up, you got to build something to gather it up and push it out. In fact, some satellites have a destruction mechanism. The satellite International Ultraviolet Explorer, IUE, when they turned it off, they sent it up and out to past geosynchronous orbit, far enough away so it's out of the mess of near-Earth asteroid dust. So that's one way of getting rid of a mission that could decay. And other ways are to decay it into the water, the Pacific Ocean. GRO, the Gamma Ray Observatory, decayed that way. It landed in the Pacific. It was the heaviest satellite, I think, ever launched, and it plunged into the Pacific. They were very careful about how they got rid of it. So they're trying, but nobody's come up with one yet.
Are the number of asteroids in the belt finite, or are they coming in from other parts of the universe? And
no, they're probably finite. We may not have seen them all yet. We may not have found them all yet, but they're finite.
Alan, you have your hand up.
I got two questions, including my standard question. But the first question is, you showed that likelihood of, people being struck, things like that. Does that increase for people that are out in space, that are on the space station? Are they more at risk from any kind of situation like that from an asteroid?
They're not so much risk at being hit by something as they are from being hit by the energy, the space nuclear, the energy. That's why the spacesuits are so bulky. That has to protect them from the sunlight, the energy from a coronal mass ejection, plasma. That's the danger. The danger of being hit by something is far less than being killed by being exposed to radiation.
Okay. Good.
That's why a lot of elements that they build, like wrenches, to build something with on space, or have to be radiation hard. They have to build them so that they can withstand the radiation. That's expensive. That's why your hammer doesn't cost 20 cents. It costs a lot of money to build a hammer that way.
Interesting. So here's my standard question, Dr. Howard. How did you get into this field of study when you were a child, or, sort of how did you?
Well, I'm an astronomer. I study galaxies. That's my main field, but I did it when I was 5 years old. And when I read a book on stars when I was 5, and I read the book and I understood the book except for one page. One page had a graph on it. 5-year-olds don't do too well with graphs. They don't quite understand what a line coming down a graph means. And it took me till high school to figure it out. So I was hooked when I was 5.
So this is a rare moment that I can share. When I was in 2nd grade or 3rd grade, my teacher, Miss Perry, she made this cardboard wall display of the solar system. And I was always into it when it was up there. And then at the end of the school year, she gave me that thing. So from that point on, I just have always been into, and I'm in an astronomy club here that's connected with NASA. Langley has an astronomy club, and I'm here in Hampton, Virginia. So I've been doing that from that teacher.
They're great programs. The astronomy clubs do great stuff.
Well, we have to end this for tonight, unfortunately, but thank you so much Dr. Howard, for coming and sharing this wonderful presentation with us and inspiring us. And thank you to all of our teachers throughout our lives for inspiring us and for the books that we've read. And may we continue to be curious about our world under our feet and above our heads, and we keep learning each and every day. And until we see you next week for, I think it's next week, I don't know. But until we meet again, stay well, stay curious, and stay outside. Take care, everybody.
Bye. You're still recording.
Bye.